Imagine descending beneath the surface of Mars into a world no human has ever seen, a world shaped by unimaginable forces where heat, pressure, and ancient fire sculpted landscapes so enormous they dwarf anything on Earth. Olympus Mons towers above the red planet like a silent titan, but what lies underneath this monstrous volcano may be even more extraordinary. Hidden chambers, collapsed caverns, frozen rivers of ancient magma, and geological scars older than any mountain chain on Earth suggest that Olympus Mons is not just a volcano, it is a geological archive of Mars's deepest secrets. But here is the question that keeps scientists awake at night. Why is this volcano so incredibly large? And does its gigantic size hide something far more mysterious beneath its foundations? NASA's high-resolution orbital scans reveal subtle patterns, anomalies deep below the crust, regions warmer than expected, fractured zones where the ground appears to have risen and fallen long after Mars supposedly went cold. These aren't the marks of a dead world, they're hints of something stirring far beneath the Martian surface, something slow, something ancient, something that may not be entirely dormant. When researchers analyzed the seismic echoes recorded by landers, they discovered faint tremors originating near the base of Olympus Mons, barely noticeable but persistent. That's when a new idea emerged. What if Olympus Mons is sitting atop a massive hotspot that never fully died out? A plume of heat still trapped deep inside Mars, slowly feeding a vast underground structure. And if that is true, it changes everything we thought we knew about the planet. Because volcanic heat does more than melt rock. It creates environments capable of sustaining liquid water, even today, melting pockets of ice trapped beneath the crust, forming hidden reservoirs shielded from radiation. Environments where microbial life, if it ever existed, might have held on. And suddenly, Olympus Mons stops being just a mountain. It becomes a gateway to the unknown, a place where the past and present of Mars collide. And as new missions prepare to scan deeper than ever before, one question rises above them all. What exactly is hiding beneath the largest volcano in the solar system, and why has it remained concealed for millions of years?
To understand the secrets beneath Olympus Mons, we have to go back billions of years to a Mars that looked nothing like the barren desert we know today. In its youth, Mars was alive with geological activity. Massive eruptions shaped continents, ancient oceans formed, and the crust shifted under the influence of internal heat. Olympus Mons began as a small volcano, one among many, but something unusual happened beneath it. The crust stayed still. Unlike Earth, where tectonic plates constantly move, Mars's surface remained frozen. That meant the same plume of magma fed the same spot for tens of millions of years. Instead of building a chain of volcanoes, it built a single monstrous structure, layer upon layer of cooled lava, rising higher and spreading wider, until Olympus Mons became a mountain with no equal. But the real story begins below. Beneath the volcano lie ancient tunnels carved by magma, now empty but perfectly preserved by the cold Martian environment. Some stretch for dozens of kilometers, forming natural caverns so large entire skyscrapers could fit inside. But deeper still are features scientists can't easily explain. Zones where the crust is thinner, temperature readings subtly higher, and mineral signatures indicate the presence of long-term heat flow. These thermal anomalies suggest that Mars may not be as geologically dead as once believed. Some models propose a partially molten layer far below Olympus Mons, a remnant chamber of semi-liquid rock slowly cooling but not yet solidified. If this is true, it could mean one thing: residual volcanic activity. Not enough to erupt at the surface, but enough to reshape the world beneath, enough to maintain subterranean heat, enough to support groundwater. And where groundwater exists, possibilities multiply. Liquid water could migrate into cracks and voids, forming hidden aquifers. It could interact with minerals, creating chemical gradients that microbes could use as an energy source. Suddenly, Olympus Mons transforms from a geological giant into a prime candidate for hidden Martian life. Not on the surface, but far below, in the warm, sheltered pockets where ancient heat still lingers. And this leads scientists to a bold hypothesis. The base of Olympus Mons may be one of the last places on Mars where habitability remained possible, a final refuge in a world that has otherwise gone silent.
But we're only beginning to understand what lies beneath this colossal mountain. When high-resolution radar scanned the terrain around Olympus Mons, scientists found enormous landslide deposits, some stretching over 700 kilometers, far larger than any landslide ever recorded on Earth. These megaslides didn't form from simple rock and dust. They were caused by catastrophic collapses deep under the volcano's flanks. Something destabilized the ground from below, and it happened multiple times throughout Mars's history. But what could have triggered such enormous events? One theory suggests that massive pockets of subsurface ice melted during periods of volcanic heating, creating layers of unstable mud that suddenly surged outward. Another proposes that shifts in underground magma chambers caused the entire region to heave like a slow-motion wave, eventually cracking open and sending billions of tons of debris sliding across the plains. But the most intriguing explanation involves a hidden network of ancient lava tubes, some so vast they make Earth's caves look tiny. If these megatubes collapsed, they could produce the huge scars we see today. And here's where it gets even more fascinating. Some of these tubes may still be intact. That makes them perfect candidates for future exploration and potential shelters for astronauts. Lava tubes offer natural radiation shielding, stable temperatures, and protection from micrometeorites. But beyond human habitation, they may serve a far more important scientific purpose. They could preserve traces of past life. If microbial organisms ever existed on Mars, lava tubes would have protected them from the planet's harsh surface conditions. And if any organisms survived underground, these tubes are where they would likely be found. Meanwhile, seismic data continues to show faint vibrations beneath Olympus Mons, tiny but consistent. Not enough to signal an eruption, but enough to imply a shifting interior. Layers settling, chambers cooling, perhaps even the movement of trapped fluids or gases. And if fluids are indeed present beneath the volcano, the implications are profound. We might be looking at one of the last active geological regions on Mars, a place where the planet's internal engine still flickers, a place where life's essential ingredient, liquid water, might still flow in hidden channels far below the ground, a place that has been holding secrets for millions of years, waiting for us to uncover them.
So what does all of this mean for the future of Mars exploration? It means that Olympus Mons is no longer just a monument to the planet's fiery past. It is a potential key to understanding Mars as a living world. Not biologically alive, perhaps, but geologically alive. Still breathing, still shifting, still capable of surprising us. Future missions will aim instruments at the base of the mountain, scanning deep beneath the crust for signs of heat, liquid reservoirs, or unusual chemical activity. If a lander or rover ever reaches the slopes, it could deploy seismic sensors to listen for the faint tremors that ripple through the ground. It could sample ancient lava flows, searching for mineral signatures created by water rock interactions. Or it could explore the mouth of a giant lava tube leading deep into the mountain's interior. And one day, perhaps not soon, but eventually, humans will stand at the foot of Olympus Mons. The mountain will rise so gradually that they won't see the summit, even after days of walking. They'll navigate canyons carved by ancient eruptions, cross plains paved with frozen lava, and descend into caverns untouched for millions of years. They may even discover environments warmed by geothermal heat, where ice melts into water in the darkness beneath the rock. And in those places, humanity might finally uncover the answer to one of our biggest questions. Did life ever find a foothold on Mars? And if it did, could it still be hiding in the warm, shadowed depths beneath this giant volcano? Olympus Mons is more than a feature on a map. It is a window into Mars's soul, a reminder that planets evolve, change, and endure long after their surfaces go cold. And as NASA, ESA, and future explorers push deeper into the red planet's mysteries, Olympus Mons will stand as both a challenge and an invitation. A towering symbol of the unknown, a silent guardian of secrets buried beneath ancient stone. And perhaps the place where the story of life on Mars begins, not on the barren surface, but under the largest volcano in the solar system, in a hidden world waiting just below our feet.